Hello and welcome to Learning Functional Programming with Rescript, Lesson 4. Today we'll be learning about the if statement, pattern matching, and exhaustiveness in pattern matching. So let's start out with the if statement. What is the syntax for it? Our if statements operate over Boolean expressions, and Boolean expressions mean anything that is true or false. If you'd like to learn more about that, we covered that in Lesson 2. So let's say we have a Boolean here, y, and we want to do one thing if it's true or another thing if it's false. So let's bind an expression to x here, which returns an integer. So the syntax of an if statement goes if some Boolean value or expression, return some value, or return another value if this expression is not true. So we have two cases here, one in the true case, one in the false case. In this case, x would be bound to the value 5. Let's rebind our y Boolean to false, and then run the same if statement over it. Now we get the value 6, because it takes this branch, the second branch, because y is false. One thing to note here is we're not actually saying return or anything like that. We're just saying 5, and then in this case, just saying 6. We don't actually have to type return or anything like that. It is implied that the last thing in each of these branches is returned. So what else can we do with if statements? Well, recall last lesson when we introduced this type, which was a variant between sunny, rainy, or snowy. Those were the three options that weather could be. So let's use this in an if statement. Let's bind current weather, which is a type of weather, to sunny. Now let's say we wanted to do something in the case where our weather was sunny, where our weather was rainy, and where our weather was snowy. Let's start out by using an if statement to do this. So let's call it weather to feeling, and it's going to be a string eventually. So what can we do here? So we have to have some if and then some Boolean expression. So we're going to be deciding over current weather here. So let's type that in. And I can choose any case for current weather and decide to do something on it. So let's say if it's sunny, I want to return the string happy because I'm happy when it's sunny. I can do else if for another if statement. We're saying else, run this if statement, combining these two cases up here. So let's say if the current weather is rainy, I'm sad. And then finally, in the last case, where it's snowy, I'll say I'm cold. All right, and something to notice here is that in each of the branches, we have to return the same type. So I couldn't return 5 here. As you can see, it's a mismatch between types. So currently as this stands, this will only run this branch because current weather is sunny. Later we'll see functions and how we can use that to variably input some type. So let's try this again with current weather equaling rainy. So this one produced happy. And on your own, what one do you think this one will produce? What string do you think this if statement will produce? So yes, it is sad. When working with variants, however, this isn't what we normally do to discriminate between the different types of a variant. You can see it's kind of long. We're doing a lot of the same thing in each of the branches. We're kind of doing the same comparison up here. So we have a way to make this more concise. This is where we use pattern matching. And the idea behind pattern matching is we have various cases that we match the exact shape of our data. So we say when we see something coming in, some variable, some binding coming in, does it match the shape sunny? Does it match the shape rainy? Or so on. So let's see what this would look like. So we're going to redefine weather to feeling. We're going to rebind it. And we're going to use pattern matching this time instead. So the syntax is switch over some variable, some binding. In this case, we're going to use current weather. We have a body of the pattern match expression. And then we have cases. So we have the case, of course, sunny. What are we returning when it's sunny? We're returning the string happy. So you can think of this as value returns something. Let's do it for the other cases. So if it's sunny, if it's rainy, to return sad. Or if it is snowy, we return cold. So in this way, we've defined the exact same expression that we've defined up here for our current variant type weather. We'll see why this case isn't exactly equal to this case a little bit later. So we have kind of a basic pattern matching example here. Let's do a pattern matching example where we have a constructor. Recall from last time we had the option type, and I will paste it here just to remind you what it looks like. So the option type takes in some type A, and you can construct either some with that type within it here, or none at all. And none does not take in anything because it represents the absence of a value. So let's make an option. Let's bind my option, which is an option over strings, to some hello world. And let's also create another binding here called my option 2, which is also an option, but is none. So let's make a pattern matching expression for options. So tell me my value will be what we're binding to. It will be a string. And then we're going to be switching. Some IDEs will do this where they automatically generate a limited switch statement for you. We're going to be switching over first my option, and then we'll also switch over my option 2 in another pattern matching expression. But for now, we're working with my option. So in the case where it's sum, bind the value that we used to create the sum into a binding x. So in this way, when we're declaring sum x, we say whatever you put in to the sum, put it into x now. So as you can see, we're kind of matching over the shape rather than the exact expression itself. So in the case where we have sum x, remember that x in this case now is a string because we put the string into the sum. So we can directly return that x. Other case, we have none, of course. And then in this case, because we don't have any value within it, we're going to directly return you didn't give me a string. So in this way, we're destructuring the sum that we built up before to pull out the string that we have within it and returning the string directly. So again, just to be clear, x in this case, because we were pulling out of the sum up here, it is equal to hello world. And then of course, because my option matches this, the overall expression is equal to hello world. Similarly, if we call this the second one, equals some string, and instead, if we copy this, if instead we switched over my option 2, which is none, recall, we return this directly. So instead of returning hello world for this expression, we return you didn't give me a string. So one other extremely, extremely powerful and useful concept in Rescript's pattern matching is exhaustiveness. This means that if you forget some value in your pattern matching expression, you didn't cover all the cases, Rescript will give you a warning and tell you directly before you even compile your program that there was an issue or a case you forgot. So let's take our weather example from earlier and expand it a little bit. So in this case, we're going to add another variant called cloudy, right? So weather can now be sunny, rainy, snowy, or cloudy. And then of course, because we already defined weather, we're going to rename it. So now we have a new weather type, which of course is the same as the old one with a case added for cloudy. Let's see what would happen if we try to use our old pattern matching expression with this new value. So in this case, we will create a weather, create current weather, which is a new, it's a weather new type, and then we'll bind it to cloudy. And let's see what happens if we're switching on this. It says you forgot to handle a possible case here. For example, cloudy. It gives us the example directly. We know exactly what we forgot to do, and Rescript told us what we have to add. So in case where it's cloudy, I'm just kind of feeling meh. And that goes away, right? We've covered all cases, and we are 100% sure of this because Rescript told us that we were forgetting a case and what we had to add to fix that case. So we're going to dive a little bit deeper into what we can do with pattern matching. So there are two things extra that we can do that will give us a little bit more power, but we have to be careful about using them. First is fall through cases. So what we can do with this pattern matching expression, for example, we can leave off the return type here if we wanted to just use the value for the next branch, right? So say if it was sunny and I'm just always sad, I'm not actually going to say that I'm happy when it's sunny. I'm still sad when it's sunny. And then my feelings only change for the snowy and cloudy. So if I directly remove this, then these both point to the sad branch. I'm saying that sunny or rainy both give me back sad. So similarly, say for snowy, I was just kind of meh because I like the cold or something like that. I could remove that. And now these snowy and cloudy both point to meh. So see, consecutive cases with one return do that return for both cases. So that's one thing we can do. Another thing we can do, which you have to be very, very, very careful about, is using the else pattern. And what this looks like, it's kind of similar to the setup we had before, but say we wanted to cover all cases not previously covered. So say I was missing snowy, right? I get this error because I forgot the case snowy. What I could do is I could replace the last case with an underscore. This means every other possible value gets a meh. But notice what we've lost here. We've lost exhaustiveness. If we added more types of weather, we would not know exactly what we had to change with this case. Rescript wouldn't tell us we had to add that weather case because it was already handled here. So be very careful when using the else pattern. almost always a bad idea to do this. Instead, directly call out each case so that you get that exhaustiveness checking. That's going to be it for today, and thank you for watching.